Okay, after you have collected your data, there's a lot of different things that you can measure in statistics. And so this section focuses mainly on measures of central tendency. In other words, things that tell you stuff about the middle of your data. So the first one we're going to look at is the mean. The mean of a set of quantitative data is the sum of the measures divided by the number of measurements contained in the data set. You guys know this as the average. When you're taking the average of something, like the average of your test scores, in statistics we use the word mean. Now the formula for mean looks like this. It's got a big Greek letter in there, sigma, x divided by n. So take a look at this data set, 3, 10, 10, 10, 117. So if you want to find the mean, what do you have to do? Add them all up and divide by the number 5, right? There are 5 elements in this data set. Okay, so when you add them all up and divide by 5, you should get 30. Okay, so now let's take a look at this Greek letter sigma. It's called summation in math, and it means take the sum of whatever follows. So the fact that you had a sigma x, the x is going to stand for the elements in your set. So in other words, take the sum of all the elements in your set, okay, sigma x, or take the sum of all the values in your data set. So on your handout, you already have these definitions. You're just filling in the symbol on the left. Let's say you have sigma parentheses and in parentheses x plus 2. That means add 2 to each value in the set. So the last data set, what we had, 3, 10, 10, 10, and 117, we'll add 2 to each of those numbers first. So that would change it to 5, 12, 12, 12, and 119. And then add up all the numbers in your list. If you have sigma x squared, that means square all the numbers in your list first. So 3 squared would be 9, 10 squared is 100, so you'd have 9, 100, 100, 100, and then whatever 117 squared is, because I can't do that in my head. And then once you square those numbers, then you total up those squares, add up all those squares. Okay, so you might see these types of formations in your formulas, okay, this sigma x, so that you understand how to interpret that. So if you have sigma x with a parentheses around it and then squared, well, order of operations is important. So for this one, it says add up all your numbers first and then square your result. So if we add up 3, 10, 10, 10, and 117, that'd be 150, and then square 150. Okay, let's say that you're asked to calculate the mean from a frequency distribution. So this time, instead of a list of numbers like I gave you before, it's all organized into a chart. So here is your formula, sigma xf over n. So notice the only difference between the last formula is that now we have this f in there. And so the x represents each data value like it did before. And then the f represents the frequency of that data value, because remember, you're looking at a chart. And so let's say that you're looking for the number 1, and the number 1 came up 4 times. So you have to do 1 times 4, and that's your first value. So xf means multiply, just like in algebra. So multiply xf, 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 and so that's your next thing. So sigma xf represents the sum of all the products obtained by multiplying each data value by its frequency. The sum of all the products. And then n represents the total frequency of the distribution. Remember how we double-checked to make sure our frequency distribution was correct? We added up all the frequencies to make sure that it added up to the same amount of items that were in our list. Well, in order to figure out how many items you have in your list, you have to add up all your frequencies. So that's going to be your n, what you're dividing by. On your handout, you have this frequency distribution. This time it's a horizontal one. So x means the data values, the types of numbers that came up. For example, This could be a frequency distribution of rolling a die. You rolled a 1 twice, you rolled a 2 5 times, you rolled a 3 once, and so on. So if you want to figure out what the mean was for this experiment of rolling a die, the first thing we have to do is what? Multiply. Good. So multiply your x value with your f value, the data value with the frequency, the number of times that it happened. Okay, so let me illustrate that in here. So 1 times 2 is 2, 2 times 5 is 10, 3 times 1 is 3, 4 times 5 is 20, 5 times 2 is 10, and 6 times 1 is 6. So notice that you can use your chart to your advantage and just use it to find all these numbers. Okay, now that we've multiplied, now we have to add. So add up all of these values that you've just found. Okay, so adding across, I heard 51. That is what I got as well. Okay, so that is your numerator of your formula. So now what do we have to do to find the n? Well, there's more than 6 numbers in our list. Add up the frequencies, right, because remember that there were only 6 numbers on a die, but when you listed what numbers you rolled, you got a 1 twice, you got a 2 5 times, you got a 3. So you actually have to figure out how many times they all came up, in other words. All right, so add up your frequencies, and what do you guys get? 16, good, that's what I got too. Okay, so substitute the 51 and the 16 into your formula and divide. So 51 divided by 16. Okay, I got 3.19, that's rounded. Or is that exact? I don't remember. Okay, so it's 3.1875. So to round it to 2 decimals is 3.19. Okay, so again, you guys were probably really familiar with finding the average of a set of numbers. This added another element to it. Maybe a lot of you hadn't done it from a chart. And so this is the best way to do it when you're looking at a frequency distribution. The next type of measure of central tendency that we're going to look at is the median. To find the median of a group of data items, you want to first arrange the data items in order from smallest to largest. If the number of data items is odd, then the median is the item in the middle of the list. Okay, so put them in order from smallest to largest, and you're looking for the exact middle of your list. Now, if the number of items is even, you don't have an exact middle. You have 2 numbers in the middle. So in that case, you want to take the mean of the 2 middle data items. So you're going to average those 2 middle numbers together. Okay, again, so first arrange from smallest to largest. Then look for the middle item if it's odd, or the 2 middle items if it's even, and take the average of those 2 middle items. All right, so find the median for the following data set: 72, 61, 85, 93, 79, and 87. So the first thing you needed to do was put the numbers in order. So 61, 72, 79, 85, 87, and 93. Do you have an even amount or an odd amount? Even. Okay, so since you have an even amount, you were to take the 2 in the middle, good, the middle 2 numbers, and then find the mean of those 2 numbers. Okay, good. So 82 is correct. So 79 plus 85 divided by 2. Now let's say that 61 was not in our original list. Okay, let's say I take that one out of there. Then now we have only 5 numbers in our list, and our median would have been 85. Good, because there is an exact middle. That's your median. Okay, so the position of the median, this could be helpful when you have a large number of data items. Now, we only had 6 numbers, so it was sort of easy to see what the middle was. But it's also helpful if your information's already in a chart to see what the position of your middle number would be. So the position is n plus 1 over 2. So for example, in that last one, we had 6 items, so 6 plus 1 over 2, which gives us 7 over 2, or 3.5. Okay, 3.5, not a middle, right? There's not a 3.5 number in our list. But this tells you that it was an even amount, right? 6. And so 3.5 is between those two middle numbers. So it would be the third and the fourth number in your list is what you're looking for. Now, the position is more helpful when you're looking at a frequency distribution. So I believe this is the same frequency distribution that we already looked at, right? Same one that's on your handout. You can double check. So 251,521 is what our frequencies are. Okay, so if we want to find the position of the median in our frequency distribution, then we take the total frequency, which is 16. We found that earlier, right? And then 16 plus 1 divided by 2. So 16 plus 1 is 17. Divided by 2 is 8.5. Okay, so then that tells us that we are looking for the 8th and 9th number in the list because we got a position of 8.5. And again, 16 is even, so they were looking for 2 middle numbers. All right, there are a couple ways that you can do this. Some of you guys are not good at visualizing what's in this chart in your head. So if you need to, you can physically list them out and say, okay, I have 2 1s, so 1, 1. I have 5 2s, so 1, 2, 3, 4, 5. How many numbers do I have so far? 7 numbers. Okay, I have 1 3, so that's the 8th number, and I have 5 4s, so 4, 4. But we don't really even have to keep going because we just needed the 8th and 9th numbers in our list, and there they are. So again, knowing what position it is makes it a little easier that you don't have to list out the whole thing to figure that out. Now, some of you guys could have done this in your head, which is what I illustrate in the PowerPoint. I say, okay, this tells us that there's 2 1s in the list. Okay, I wrote it down, but this, if you're doing it in your head. Whoops, that's not what I wanted. Wait, oh, okay, it erased. Let me go back. Okay, there's 2 1s in the list. There's 5 2s, so that's 7 so far. The 8th number is a 3. And then the next 5 numbers are 4, so the 9th is a 4. Again, exactly what I just wrote them out, you can do in your head that way. So using that 3 and 4, 3 plus 4 is 7, divided by 2 is 3.5. So that is the median of this list. Remember that our mean was 3.19, and our median is 3.5. Okay, the next type of central tendency that we're looking at is the mode. The mode is the data value that occurs most often in a data set. If no data items are repeated, then the data set has no mode. So if every single item shows up only once, no mode. If more than one data value has the highest frequency, then each of these data values is a mode. So let's say that there are 2 numbers that pop up 3 times, and that's the most that some number pops up. Both of those numbers are considered the mode. So there could be no mode, there could be 1 mode, or there could be multiple modes. If this is our list of numbers, what is our mode? Okay, I heard 7, because 7 shows up 3 times, right, the most amount of times. Okay, I still have one more central tendency, so don't pack up early, please. All right, if we are looking at a frequency distribution, oh, let me go back to that other frequency distribution. If you're looking at this frequency distribution, then which number is your mode? Okay, 2 and 4 is correct. Good. So notice that you're looking to see which one has the highest frequency first, and the highest frequencies are 5s. They have a tie, but our answer is the actual data value. So our modes are 2 and 4. Okay, because they each showed up the most amount of times at a 5. And then the last one is the mid-range. The mid-range is found by adding the lowest and the highest data values and dividing by 2. So if you don't have your handout, you really just need to write down the formula. Okay, the lowest value plus the highest value divided by 2. The example could be looking at that frequency distribution of rolling the die. The lowest value is a 1. The highest value is a 6. So 1 plus 6 is 7, divided by 2 is 3.5. Notice that some of your central tendencies could end up being the same number. So the median and the mid-range are both 3.5. Sometimes all of them could be the same exact number. You're also going to be asked to find these items from a frequency distribution. So if you're looking at the histogram, finding the mean would be the same way as doing the chart, except you have to multiply the item by its height. Okay, if that makes sense. So instead of 1 times 2, in your chart, you have to do 1 times the height of 2 in there. It's the same formulas, but it's looking at it in a different way.